the lecture series of operating systems. In last lectures, we have seen about the topics of introduction to operating systems, components of a computer, hardware, operating systems, applications, and users. And we have seen the modes of operation, the dual mode, multi-mode, and the operating system operation as a type. Okay, and then also we have seen some 6 functionalities of operating system: process management, memory management, file management, batch management, the protection and security, as well as the command line interface. So in this lecture, we will be seeing about the types of operating systems. So you can see on the screen, the operating system is broadly divided into 6 categories. So first is the batch operating system, and then we have single user operating systems, in which single user single tasking is one type, and the single user multitasking operating system. Then we have multi-user multitasking, multi-processing, time sharing, and real-time operating systems. So now let us see each and every type of operating system in detail. So before going with the processing, actually the concept of operating system has evolved. Before the concept has been evolved, we used to process the instructions in a computer through serial processing. So in serial processing, so at that time in the 1950s, in the early 1950s, each and every instruction is being executed through serial processing. So as you can observe, in those times, each and every device, each and every component, the hardware component of a computer used to be of a huge size. Say for example of a room size. Say if you want to interact with the computer, the input device will be in one room, computing machine, the CPU which we are calling now, will be in one room, and the output device will be in the other room. So let us see how the processing is done using these 3 devices. First step, we need to type the input. So just remember that in each and every process, when you are executing, the instructions will be of only 3 categories. One is the input instruction, the processing instruction, and the output instructions. So only whichever the program or how many number of instructions you may include, the program will consist of only these 3 types of instructions. So the first thing, in order to execute a program or in order to perform some specific task, the first thing you need to do is you need to provide an input to the system, and that input is provided by using a punched card. In olden days, there is no keyboard devices or mouse device. So in order to take input, we need to use the punched card. So the punched card is a card which looks like a postcard, and the input is given by punching the holes on the punched card. So there is an input device called card reader, which is used to read the data present on the punched card in the form of holes. So this card reader will read the input data and send the data to the computing machine. So this computing machine will check whether the given data is free from errors or not. Here you see there is at this point there is no concept of software. So the errors is indicated through the lights. The green light will be indicating that your program is error free, whereas the red light will be indicating that your program is error prone. So by seeing if the program is error free, then the program is executed and then it is sent to the output machine in order to print the output. Whereas if your program has errors, those errors were indicated only through the red light. So if the red light is given by the computing machine, the user again have to check the registers. So that is, the user will directly interact with the hardware here, because there is no software to act as a mediator between the user and the hardware. So the user will check the registers. So how he will check whether the data, what the data is present and what is the error. So we have already discussed that these memory chips are made up of capacitors, and these capacitors, if a capacitor is charged fully, then it indicates 1, and if it is not charged, it indicates 0. So in that case, the user will go to registers the memory device and check all the capacitors for the residing data. So he cannot identify soon where the actual error has been occurred. So if he identifies the error, he should again start right from the first step, that is punching the giving the data on the punched card, and again he should repeat all the steps again. So here if you observe, the main drawback of this kind of processing is even a single instruction cannot be executed without the user interaction. So in order to overcome this disadvantage, to reduce the user interaction, we have got the concept of operating systems. So now we will see the next or the first type of operating system which was evolved in 1960s. So that is the batch operating system. So from here, if you observe, each and every operating system, the what is the main functionality of that operating system can be given by observing the name of that operating system itself. So if you see, the first operating system is the batch operating system. So batch, what is a batch? It is a collection of some items. So a collection or a group is called a batch. So here in this type of operating system, all the data or the programs or the instructions which has to be executed are collected as a batch. See, each and every data or each and every instruction, those were collected or called jobs. So these jobs are collected together and made as different batches or groups. So these groups will be executed finally. So until and unless all the data is gained, the operating system will not start executing that program. So as an example, you can consider a payroll. So payroll is nothing but defining the salaries for employees. Say for example, if you consider an organization, so all the employees, the salary of each employee is calculated based on their thumb impression, let us say. So in this case, each and every employee will only interact with the system in order to put their thumb impression. So if, let us think, in the morning they will put a thumb, and in the evening while leaving the organization they will be putting a thumb. Other than that, the user will not perform any task with that system. So automatically when the salary is calculated after, say for example, for each month the salary is calculated. So after 30 days, all these data are collected at a time, and then the data which is collected for all these 30 days can be created as a batch and then executed at last. So this you can see as a in a diagrammatic format. So if you observe this diagram, there are number of users. Say if you think each user as a faculty or say for example an employee. So the job one is the one which the 30 days which consists of the 30 days data of the first user. So likewise, n users have n number of data. So n jobs, and these jobs are given to the operating system. So this operating system will make some number of jobs into one batch and then gives it to the CPU in order to execute. Then now let us see the advantages and disadvantages of your batch operating system. So if you see here, there is very little user interaction. So which we have thought as a disadvantage during the serial processing, that was overcome here and became an advantage. So there is no or very little user interaction with the operating system, and there is increased performance. How can we say that there is an increased performance? So as soon as one job is executed or one batch of data is executed, immediately the next batch of data is coming for execution. And in this batch operating system, you can consider the disadvantages as only one single job will be executed at a time. So if that job is being executed or that batch of data is being executed, no other data can be executed at a time. And also it is difficult to debug the program. You cannot find the where the errors have actually occurred. So even if the program went into infinite loop, you cannot be able to rectify or stop the processing. So with these disadvantages, we'll go with the next operating system, that is single user, single tasking operating system. So single user, single tasking, in the name itself describes that only one single user can interact with the operating system and he can perform only one single task at a time. Okay, so the best example for this type of operating system is the Palm OS. So the Palm OS is nothing but the operating system which is uh, installed in a device of palm size, the mobile device. So olden days, the mobile devices, the basic mobile device used to be of palm size, and the operating system which is installed in that is. Sir, 10-15 minutes అయిపోయింది అక్కడ ఇంకా ఓపెన్ చేయలేదు సార్ మార్నింగ్, సో ఇక్కడ స్టార్ట్ చేసాం ఒకటి లేదా అయిపోతుంది 10 minutes. So the best example here is the Palm OS. So this Palm OS is the operating system which is installed in a mobile device used in olden days, and this mobile device used to be of palm size. And that in this operating system, if you are trying to listen music, if you are listening music, you cannot open the other application, so that you cannot open photos, say for example. So likewise, you can only perform one single task at a time. And the next, before going to single user multitasking, let us see the concept of multi-programming. So in single user single tasking, we have seen only one single task can be performed at a time, can be executed at a time. In this multi-programming, when a number of jobs can be executed at a time. So these number of jobs or process will share the same CPU. That is, your system will consist of only one processor, whereas the number of process coming at a time for execution will be residing in the main memory. So each and every job, so say for example, we have got two processes at a time for execution. So the process which appeared first will be given the CPU for execution, and the next process which has appeared next will be residing in the main memory. So while the process 1 is being executed, the process 1 may go out for some resource from the CPU. Say for example, to take input, the process control should move out from the CPU and then go for the input resource. So at that time, the CPU will allocate its time in order to execute the second process. Likewise, a single CPU is shared for all the processes appearing for execution at the same time. So the why do we need this programming is in order to maximize the CPU utilization. See, if you observe the single tasking operating system, whatever the program you are executing, when your program control goes out from some other resource, until then the CPU sits idle without executing any instruction. So as the CPU has the capacity of executing millions of instructions within a second, it is a waste of time for CPU in order to sit idle until the process gets the data from the required resource. So for that, we have introduced this multi-programming concept. So next, if you see the layout of the main memory, as we have discussed, the operating system is the only program which is being run right from the power on time of the system to the shutdown time. That is, the operating system will keeps on running until the system is on. So and we also discussed that each and everything that is running behind, or that is running in a computer, should be placed on the RAM. So for that purpose, your RAM space, some of the space in your main memory, that is the RAM chip, will be reserved for the operating system files, and the remaining empty space will be allocated for the jobs or process which are coming for execution to the CPU. So if you observe the diagram, the operating system, the green part is reserved for the operating system files, whereas there are number of n jobs which are appeared in order to get executed with the CPU. So job 1 will be given the first CPU time. When the job 1's control is out of the CPU for some resource, the next job will be coming into the CPU for execution. Then, with this concept, we'll go with the next operating system, the single user multitasking operating system. So in single user multitasking, uh, the processing is done based on the multi-programming concept. Okay, so it allows, as you can see, I told already, based on the name only you can tell what the operating system is going to do. So it allows only single user to access the computer or to access the resources, whereas that single user can perform multiple tasks at a time. Okay, so the best example of this type of operating system is the Windows and Mac operating system. See, if you observe when you're using the computers in lab, or when you're using the computers with Windows operating system, you can create two or more multiple accounts in your system. So with that, if say for example we have two accounts, the admin and the user. So if you are logging into admin, you cannot perform or you cannot access the files present in the user account. Okay, so in such case, this Windows operating system will allow only single user to interact with the system at a time, but after logging into one account, you can simultaneously perform many actions like opening your video or opening some music. At the same time, you can view photos or you can perform some text processing using your Word document. So likewise, multiple tasks can be performed at a time, whereas you can only interact with the computer, only one single user can interact with the computer. So next we'll see the advantages and disadvantages of this multitasking operating system. So in this it gives the time saving. It performs multiple tasks at the same time, yielding high productivity. High productivity in the sense within less time, yielding more result. Okay, and the disadvantage is the operating system is highly complex. So how we can say that it is complex? Because as we have discussed, when one job is leaving the CPU for some resource, the operating system should keep track of at which point of time the instruction is going out, and the program or the process is going out, and what are the number of instructions that are already being executed, and what is the next instruction to be executed when the process come back. So all these data should be saved by the operating system, which includes more calculations and complexity. So next we have the multi-user multitasking operating system. So if you observe, in single user only one user can interact at a time, whereas multi-user, number of users can simultaneously interact with one computer and they can perform multiple tasks at a time. So the best example for this type of operating system is the Unix operating system. So you already worked out with it in your labs, like when you're trying to execute your program or trying to create your program using your putty. So you are all aware of your putty software, right? So if you observe in your labs, when you are trying to create a folder, so you will need to log in before uh, performing some specific task. So you will have different login IDs and passwords. So and can you able to edit or can you able to log in without running the system which is present in your server room? We cannot, right? So that is the multi-user multitasking operating system. The original operating system files are originally installed in only one single main computer, and there are number of computers. It allows number of computers, different devices, in order to connect with the main computer. So that main computer is called the terminal server, whereas the other computers which are connecting to that main computer is called the terminal client. And then if you observe the diagram here, the FDI server is the main computer which consists of all the FDI files, and there are different devices which are connecting to that server. So if you observe FDI client engineering, one device is performing some engineering task. So some next device is going for device management, asset management, portable, field level, device package. So likewise, different clients or different users can connect to the server for performing different purposes. What are the let us see what are the advantages and disadvantages of this multi-user multitasking. It is highly productive. So highly productive in the sense you can perform multiple tasks at the same time, and within short time you can get more number of results. You can be able to execute more number of tasks, and it is also time saving. Time saving because we can execute within one process execution time, we can execute multiple process. So what is the disadvantage here is if the connection to the main system, that is the server, is lost, the clients will not be able to perform any action using that operating system. So this is considered as a main disadvantage of your multi-user multitasking. Then now we have the multi-processing operating system. So what is the multi-processing? So when your system consists of multiple number of CPUs, that is your process. So then your when your operating system supports multiple process, then that type of operating system is called multi-processing. So in multi-programming or multitasking, what we have done, we are sharing only one single CPU or one single processor to all the jobs which are present readily in the main memory. Whereas in this type of multi-processing operating system, there can be more than one processor, so that if your system, say for example, if it is consisting of two processors, then your system is capable of executing two processes at a time. So in multi-programming, when one job goes out for a resource, then only you can allocate second process for execution. Whereas in multi-processing, as there are two processors, simultaneously two processes can be executed at a time. And now when there are these multiple processes present in your system, these multiple processes must be able to communicate with each other in order to think how the what are the cables, the buses which are used to transfer the data. So what are the buses that should be used for processor 1, and what are the buses that should be used for second processor, what is the memory that should be used by each processor, and what are the peripheral devices that should be shared by each processor. And these types of systems are used, these type of operating systems are used when there is high and lots of data to be processed. And then the main applications where this multiprocessing is used is in satellite controlling and then weather forecasting, because we'll be getting more and more large volumes of data. And now we'll see what are the types of multiprocessing. So mainly we can see two types of multiprocessings. So in that, if say for example, if two process, we are containing two process in our system, and if two process share the same main memory. So if two process share the same single main memory, such process are called the tightly coupled process, multiprocessing. Whereas if they have their own memory, that is, if within the processor, if there are number of registers and cache memories, then that type of processing is called the loosely coupled multiprocessing. So if you observe the diagram, what type of coupling it is? It is tightly coupled because both the I/O processors are sharing the same main memory. So now let us see the motherboard layout consisting of four processors. So you can see the four silver slots here, so which are used to insert four processors. I think you have already heard about the dual and quad core processors. So dual core in the sense your operating system is supporting two processors at a time in your computer, whereas quad core in the sense your operating system is supporting four processors at a time. So the multi-core, you will be also hearing about the multi-core. More than one processor, where whenever you are using more than one processor, we can call it as multi-core processing. And next we'll see about these types of multiprocessing. So based on tightly or whatever it is, either it is the tightly coupling or loosely coupling, these there are two types of multiprocessing. Multiple processors are present in your computer, and out of all the processors, if one process have all the permissions, that processor is called boss processor, and the remaining processors are called worker processors. This boss processor will control all the operations and the specific tasks that should be done by the worker processors. If the multiprocessors have this kind of relationship, that is the boss and worker relationship or the master slave relationship, then that kind of operating system is called asymmetric multiprocessing operating system. And when there is no concept of boss worker relationship, that is, if all the processors are considered as peers. What is this peers again? So peers in the sense all the devices present, that is the all the processors present are of same priority. So no boss or worker relationship or master slave relationship between the process. So such process are called the symmetric. Such type of operating system is called symmetric multiprocessing operating system. So next we have the time sharing operating system. So in multi-programming, we have seen that the job is leaving the CPU only when the event has occurred. Event in the sense when it needs some resource. Okay. Whereas in time sharing operating system, the job will leave the CPU only after completing the stipulated time. That is, the CPU is given a small time slot in order to execute a process. So after, if whatever the stage the process may be, if that process did not, even it did not complete its execution, and if the CPU time slot is completed, the process will leave or suspend its execution, and the CPU time is allocated for next process in order to execute. And that small slot of time is called the time slice or time quantum. And you can see, as you can see the diagram, there are number of users who are interacting with the computer, and with each user with each different job. So when these users are trying to execute their process at the same time, each user is executed, each job of a user is executed only with that particular time slot. Say for example, we have given some 15 microseconds for each job. So if the user wanted 20 microseconds to execute, only the first 15 seconds, 15 microseconds, the user job is executed. After completing the 15 microseconds, the next job is given the CPU time. Later on, after completing all the jobs of the given users, again the first process will come into execution. But the user cannot recognize that there is the pause between each job of there is a pause between his job, because as we have mentioned it, the time slot is very small, that is in milliseconds. So as a human being, we cannot recognize this very fraction of seconds time. So the user will think that his job is continuously being executed, but what actually is done in the background is each job will get paused after completing its time slot. So that is about the time sharing operating system. And next we'll see about the real time operating systems. So these real time operating systems are used in order to control the mechanical machinery and the scientific instruments. So what is the main objective of this type of operating system is in order to provide quick and predictable response to the events. So say for example, where we actually use these real-time operating systems is when we need to execute a high priority job. So what is this high priority job again? Let us take an example. Let us think a user is moving in a car. A user is driving in a car. So what are the operations we can do while driving a car? So we can listen music, right? So by listening music, he is moving his car. So say for example, if he met with an accident, So as soon as he met with an accident, we have a feature in our cars that opening of airbags. So immediately, as soon as he met with an accident, the airbags may cause the user to lose his life. In order to make the user but if you observe, as soon as we met with an accident, a human being by himself cannot press the button to open the airbag. This task should be performed automatically without user interaction. So in such cases, the real-time operating systems will come into existence. So those that action, the opening of that airbag action is called the high priority job. So these real-time operating systems will work, or the processing is done either event driven or time sharing. Event driven is nothing but the multi-programming operating system. So either of the cases the processing may be done. So while executing this process, if a high priority job is coming, systems will stop the execution of process in whichever stage they may be and starts executing the high priority job. So the main applications of these are maybe in robots, cars, satellites, rockets, all these are using real-time operating systems. So these are the types of different operating systems available. Now we'll see why do we need all these different operating systems. Why such different operating systems should be used. We can give all the features in one single operating system and we can use. So why actually we need these different operating systems? Because each and every task that user is going to perform will have only some specific actions to be performed, and each operating system is designed in order to fulfill that particular needs of the user. So we'll select an operating system based on our user requirement. So if you see the batch operating system may not require much of the user interaction. Uh, and whereas there is no high priority jobs when considering the payroll example. So in such case, a batch operating system is enough for the user in order to accomplish his task. So that's why we have different types of operating systems. So thank you for watching this video. In next lecture, we'll see the operating system services. Thank you for watching.